Session 8.1 Basic of Hypothesis Testing. Let's look at the example of null hypothesis and alternate hypothesis. The mean number of calories burned per workout by members of the fitness center is at least 500 calories. You want to test if members actually burn less than 500 calories. First, we need to know what is the hypothesis. Hypothesis is a statement about a population parameter. It can be the mean, it can be proportion, standard deviation, or variance that we want to test using the sample data. And we have the null hypothesis. Null hypothesis, we use the H0 to represent it. And null hypothesis represents the status quo or the claim we assume true until evidence suggests otherwise. It contains the equality. For the null hypothesis, we always use equal or less than or equal to or greater than or equal to represent it. All of them, they will be contains the equal sign. For our example, look at the claim statement one more time. Mean number of the calories. So we need to decide which population parameter we are working on it. So you could see there's a mean. So we do have the mean here. And then they talk about the calories burned out is at least 500 calories. So my null hypothesis, first, population parameter, that will be the mean, right? There's a mean here. At least that is a greater than or equal to 500 calories. Okay, we do have the null hypothesis. And then how about the alternate hypothesis? Alternate hypothesis, you can use the H1 or HA or HA here. Okay, the lowercase letter and the capital letter of the A. You could use either one of this to represent your alternate hypothesis. And alternate hypothesis represent what we want to test or prove. And it contains not equal to or strictly greater than or strictly less than. Since our null hypothesis is going to be mean greater than or equal to 500 calories, so my alternate hypothesis, that will be opposite with this guy. So that will be mean strictly less than 500 calories. Okay, I'm going to explain more about the null and alternate hypothesis. We do have three types of alternate hypothesis. First one, a left tail alternate hypothesis state that the parameter is less than the value specified by the null hypothesis. So our example, our alternate hypothesis will be mean strictly less than 500. Okay, we'll be using the left tail test because we do have a strictly less than. Second one, a white tail test. A white tail alternate hypothesis state that the parameter is going to be greater than the value specified by the null hypothesis. It can be weighted as the mean strictly greater than 500. And since this is going to be greater than, we'll be using the white tail test. Okay, so the picture is going to be looks like that. Okay, left tail, white tail. And then the last one, we do have the two-tail test. A two-tail alternate hypothesis state that the parameter is not equal to the value specified by the null hypothesis. So for example, if we have the mean not equal to 500, then we will be working on the two-tail test. So to determine which tail test we'll be using, that will be according to your alternate hypothesis. For our course, we only study the population proportion or population mean. So you're gonna see we only have these two population parameter. For your null hypothesis, first, with the claim statement, make sure if they are talking about the proportion or the population mean. And then for the null hypothesis, we can have an equal, less than or equal to, or greater than or equal to. Okay, that would be the null hypothesis. is always contain equal sign here. And for your alternate hypothesis, it can be the P stand for the population proportion or population mean. That will be not equal to, greater than, or strictly less than. When we're working on not equal to, that is a two-tail test. Greater than, that will be right tail. Less than, that will be left tail test. And then you're gonna see this is gonna be a pair. Okay? Because no and alternate hypothesis is gonna be complementary. It means they're gonna take everything. If this is an equal, then alternate hypothesis, that will be not equal to. When you have the less than or equal to, then your alternate hypothesis, it has to be strictly greater than. When you have a greater than or equal to, then your alternate hypothesis, that will be strictly less than. So this is always be a pair because they are complementary. Or for your null hypothesis, you can always stick with the equal sign here. Okay, instead of writing like less than or equal to or greater than or equal to, you could just write it down as an equal sign. When you guys read like most of the statistic book, they usually using equal for your null hypothesis. Okay, both of them are correct. It really depends on which one you're gonna pick. But for the alternate hypothesis, that will be the same thing. Either not equal to, strictly greater than, or strictly less than. Okay, so on the test or the homework, feel free to choose this one or this guy. Okay, hypothesis testing. The first thing you need to do, you need to know how to state the null and alternate hypothesis. Let's try on this example. The mean weight of beauty pageant winner is 116 pounds. Study of 16 randomly select beauty pageants results in a mean winner weight of 115 pounds. Express the original claim in symbolic form and state the appropriate null and alternate hypothesis. Okay, so we need to do two things. First, state the original claim in the symbolic form. This is talking about, I want you guys translate the claim statement from English to the math equation here. So first, we're gonna write down the original claim. We need to think about it, which population parameter they are working on it. Are they working for the mean or proportion? So with the claim statement one more time, the mean weight of beauty pageant winners is 116 pounds. So we are working on the mean. Okay? Then is 116 pounds this is represent equal to 116. So this is gonna be the original claim from the claim statement here. Now we're gonna write down the null and alternate hypothesis. Since we do have the equal to, okay, equal to, that will belong to your null hypothesis. So my null hypothesis, that will be the same thing, mean equal to 116. And then what is your alternate hypothesis? That will be always opposite to your null hypothesis. When this is equal, then your alternate hypothesis, that will be not equal to. Then which tail test will be using? Left tail, right tail, or two tail? That will be looking at the alternate hypothesis, not equal to, so that will be two tail test. Okay, B. The claim statement, less than 25% of adults in the city commute by bicycle. A survey of 400 adults in the city shows that 22% commute by bicycle. So, original claim. Think about it. Which population parameter we are working on it? Is it the mean or the proportion? When the question, they never mention about the mean or standard deviation, that will be the proportion. Okay, so we're gonna put the P here. And then they say less than 25%. So this is the claim statement. Less than, that will be strictly less than 0.25. Okay, after we have the original claim, so think about it, strictly less than. Strictly less than, that will be from your alternate hypothesis. Okay. So my alternate hypothesis, that will be P strictly less than 0.25. And then think about it, what is your null hypothesis? That would be opposite to the alternate hypothesis, right? So H naught, that would be P greater than or equal to 0.25. Or you can state the null hypothesis, that's a P equal to 0.25. That is up to you guys. You could just say this one has your answer, or put it like greater than or equal to has your answer. And then when we have the less than, so that will be left tail. Okay, C. The average daily screen time for teenagers is at most 4 hours. A study of 120 teens find an average of 4.3 hours with the standard deviation of 1.2 hours. State the appropriate null and alternate hypothesis. So I want you guys try. Think about it, which population parameter will be mean or proportion. They're talking about the average screen time, right? So they're talking about the mean. And at most, okay, at most, that will be the inequality of less than or equal to 4. Since we do have the equal sign, so that will be same as the null hypothesis. Or you can write it as the null hypothesis, the mean equal to 4. And then alternate hypothesis, that will be opposite with this guy, so that will be greater than, strictly greater than 4. And when we have a greater than, that will be white-tail test. Okay, last one. At least 45% of internet users pay bills online. When we're working on the null and alternate hypothesis, we only need to pay attention for the claim statement here. Okay, so original claim. Which population parameter we are working on it? They never mention about the mean or standard deviation, right? So that will be the P. At least that will be greater than or equal to 0.45. And again, we do have the equal sign here, so that will be belong to the null hypothesis. Okay, or you can write it as a equal. Okay, either one of them. Alternate hypothesis, that will be opposite with this guy, so that will be less than. And since this is a less than, so that will be left tail. Okay, so now you guys know how to state the null and alternate hypothesis. Second part, select the significance level. Significance level is the threshold for decision making in hypothesis testing. It tells us how much evidence we need before we reject the null hypothesis. Common choice for the alpha, that will be 5% or 1%. Okay, we talk about this guy from the previous chapters when we working on construct the confidence interval. Remember that when we construct the confidence interval, we talk about the critical value, right? And then we do have the alpha. For example, we're working on 95% confidence level. So we're gonna say in the middle part here, there'll be 95%. And then alpha, that will be the area of left tail plus the area of the right tail. That will be equal to your alpha. This is the same thing with the confidence interval, the alpha. Okay, we call significance level. And usually for this case, significance level will be given. Okay, usually 5% or 1%. Sometimes they will be working on like 10% as well. And for the hypothesis testing, we mentioned about it. We do have 3 types of alternate hypothesis, right? And then we have a left tail when you have a strictly less than, and when we have the left tail, so you're gonna see this one. This is belong to your significance level. If your significance level is gonna be 0.05, that means the area of the left tail here, that will be 0.05. And then what is the alpha in here? This is talking about the probability that the event is unusual. Okay, the event is unusual on this part. So the big parts here, that's talking about the event will be usual. Same idea, when you have the alternate hypothesis is going to be greater than, that will be the white tail test. And the alpha is talking about the area of the white tail. Same thing, probability in this part, the event will be unusual. When you have the two-tail test, sum of these two tails area, that will be equal to the alpha, just like the confidence interval. Okay, so for this case, significance level is always be given. Okay, test statistic. Test statistic is a value used in making a decision about the null hypothesis and is found by converting the sample statistic to a score with the assumption that the null hypothesis is true. Okay, let me explain this part. First, let's say I do have the null and alternate hypothesis. And then since this is less than, so we have the left tail test. So my picture's gonna be looks like this, right? And then we talk about it when we have the left tail test, the area of the left tail, that will be equal to your significance level. And this part, this is represent the event is going to be unusual. And this part, that will represent the probability of the event will be unusual, and this part. And here, we'll be assuming your null hypothesis is going to be lying from here. Okay, remember at the beginning we talked about it, for the null hypothesis, we always assume that will be true, right? So the null hypothesis is going to be staying on this part. And our alternate hypothesis, that will be lying in this tail here. Okay, now, then we do have the formula called test statistic. Okay, it depends on which population parameter you're working on it. I'm using the proportion as my example. So this guy, that will be the test statistic for the proportion. So what we're gonna do, we will be collect the sample, find out the sample proportion. And then depends on your sample size, how many samples you're gonna be collect, and then we're gonna plug in here. Okay, we'll be using the sampling data to find it out the test statistic, the z-score in here. If after you collect the sample data, you find it out your test statistic is going to be located at this part, that means we'll be reject the null hypothesis. It means the evidence strongly support the alternate hypothesis. Okay, one more time. After we collect the sample data, we plug in to the formula of the test statistic, and then we find out the z-score. If your z-score is located on the left tail at this part, then we're gonna say reject the H0, reject the null hypothesis. We do have a sufficient evidence to support the alternate hypothesis will be true. But if you collect the sample data, you find it out your test statistic is located somewhere like here, then we're gonna say fail to reject. Okay, we don't have enough evidence to conclude the null hypothesis is false. Okay, so we only have the two decisions. Either you reject it, we believe alternate hypothesis is true, or we fail to reject. We do not have a sufficient evidence to conclude the null hypothesis is false here. Okay, so remember the significance level is always given, but the significance level talking about the area of the left tail. And your z-score, when you find it out from the test statistic, this is just the z-score of the number in here. So how can we compare the value of the z and the significance level? So what we're gonna do? So we'll be introduced the p-value. P-value is the probability of getting a sample result as extreme as the one you observed, assuming the null hypothesis is true. So look at this left tail example. When we find the C, the test statistic, we're gonna put it in here. And this one, this is talking about the more extreme values on your left tail here. And that will be your p-value. P-value is talking about the area of the left tail here. Okay, one more time. After we collect the sample data, we use the formula, find out the test statistic. Okay, and then the test statistic will help you guys find out the area of the left tail. And this area of the left tail, that will be equal to your p-value. So use test statistic to find the p-value, which is going to be the area, and then you're going to compare with your significance level. Okay, so let's say this is going to be my significance level, and my test statistic is going to be located here. So this part, that will be the p-value, which is going to be your area of the left tail here. P-value method saying that after you find the p-value, you're gonna compare with your significance level. If the p-value that will be less than the significance level, then you're gonna reject the H0. Okay, we reject the H0. It means we do have a strong evidence to support the alternate hypothesis. But if this is my significance level, and my test statistic is located here, and I use the test statistic to find the p-value, and I compare with your significance level. If p-value greater than the significance level, then we're gonna say fail to reject the null hypothesis. We do not have sufficient evidence to conclude that the null hypothesis is false. Okay, I need you guys remember this part here, the p-value. So in this line, we just emphasize to say it one more time. After you find the test statistic, you use the test statistic to find the p-value, which is going to be your area. And then you compare with your significance level. Okay, so if your test statistic on the left tail, this is going to be your p-value. If your test statistic on the right tail, this part, that will be your p-value. So for the two tail, when you find the test statistic either positive or negative, and then you use that to find the area of either left tail or right tail, make sure you multiply by 2, because the p-value will be the both area here. Work on this example. More than 60% of adults prefer online shopping. A recent survey of 500 adults shows that 62% prefer online shopping. Assume significance level equal to 0.05. And the given the test statistic is going to be 1.8. State the appropriate null and alternate hypothesis, and then find and interpret the p-value. So first, think about it. What is your original claim? More than 60% of adults prefer online shopping. Okay, think about it. Which population parameter they are working on it? Are they working on the proportion or the mean? They never mention about the mean or standard deviation, so that would be the proportion, right? And then more than 60%. So we have strictly greater than 0.60. Okay, now I want you guys try to find the null and alternate hypothesis. Tell me which tail test you guys using. Okay, after we have the original claim, we do have a strictly greater than, and that will be the alternate hypothesis, right? And then null hypothesis, opposite of this guy, that will be less than or equal to. And this is going to be the white tail test. Okay, so white tail test here. And then given the test statistic is going to be 1.8. Okay, so 1.8 somewhere like here. And then we want to find the p-value. P-value will be the area of your white tail here. So remember on the previous chapter, we learned that when they given the z-score, how can you find the area? We'll be using the normal CDF, right? Normal CDF, lower value, and then upper value. Since we're working on the standard normal distribution with the z-score, right? So the mean will be equal to 0, standard deviation, that will be equal to 1. Okay? So p-value, lower value, upper value, that will be 1e99. Use your calculator. You're gonna get 0.0359. Okay, after we find the p-value, we need to interpret. Okay, interpret the p-value. So I know my p-value, that's a 0.0359. And then my significance level, that will be 0.05, right? It's given. So will it be greater than or less than? That will be less than, right? When the p-value less than the significance level, we're going to reject. Okay, another example. The proportion of customers who prefer home delivery is different from 50%. A survey of 400 customers shows that 54% prefer home delivery. Assume the significance level 0.05. Test statistic is going to be equal to 2. State the appropriate, the null and alternate hypothesis. And then find and interpret the p-value. Okay, so when you guys try, state the original claim first, and then null and alternate hypothesis. State which tail test we'll be using. So we will have not equal to 0.50. And not equal to, that will be your alternate hypothesis. Okay, then your null hypothesis will be opposite with this guy, so that'll be equal. And this is gonna be the two-tail test. Okay, so two-tail, and then the test statistic is gonna be 2.00, so somewhere like here. And where is our p-value? P-value will be the area of the left tail plus the area of the white tail. Right now, we only have the test statistic on the white tail. So after you use the test statistic to find out the area of the white tail, you need to multiply by 2. So normal CDF, lower value to upper value, which is going to be 1e99. And you should got this guy. And this is only the area of your white tail. So p-value, you need to be multiplied by 2, which is going to be 0.0456. After you find the p-value, you need to compare with your significance level, right? 0.0456 and then 0.05, that will be your significance level. So that will be less than or equal to. And we're going to reject the null hypothesis. So we reject this guy means we do have a sufficient evidence to support the alternate hypothesis. Okay, key components of a hypothesis test conclusion. Decision. State clearly whether you reject the null hypothesis or fail to reject it. When you reject it, this means we do have enough statistical evidence to support the alternate hypothesis. Okay, one more time. When we reject this guy, so that means we do have a sufficient evidence to support the proportion is not equal to 0.50. But if I say fail to reject, it means we do not have enough evidence to support the alternate hypothesis. But it doesn't mean the null hypothesis is true. We only can say we don't have enough evidence to support the alternate hypothesis only. Interpretation in context. Explain what your statistical decision means in plain, non-technical terms related to the real-world scenario of your initial hypothesis. When you reject the null hypothesis, you're going to state there is sufficient evidence to support the alternate hypothesis. You could write down the claim statement here. But when you fail to reject, then you're going to say there is not sufficient evidence to support your claim statement here. You guys may need to read the claim statement clearly when you join the conclusion. Okay, example 4. We're going to refer to the example 2. We did these questions already. We state the null alternate hypothesis. We find out the p-value, right? And then we reject the null hypothesis. So when we reject it, it means we do have a sufficient evidence to support the alternate hypothesis. So we're going to say that there is sufficient evidence to support the claim that, copy the claim statement here, more than 60% of the adult prefer online shopping. Okay, because this is going to be your alternate hypothesis. The average daily screen time for college students is less than 6 hours. Okay, so when you're gonna say fail to reject, there is not sufficient evidence to support the claim that the average daily screen time for college student is less than 6 hours. So for these sessions, we learn how to write down the null and alternate hypothesis. We talk about the p-value, how to find your p-value and interpret the p-value. Also, how to draw the conclusion here. So on the session 8.2, 8.3, we're gonna combine everything together to perform the hypothesis testing. That's it.